How does mass energy equivalence connect to energy conservation? Imagine a tiny amount of matter transforming into a burst of energy. That's the core idea behind mass energy equivalence, expressed by Einstein's famous equation. It tells us that mass and energy are two sides of the same coin. When a small piece of mass changes, a huge amount of energy is involved. This concept links directly to the energy conservation principle, which is a key part of the first law of thermodynamics. The first law says energy cannot be created or destroyed, only changed from one form to another. Now, with mass energy equivalence, we see that mass itself is a form of energy. So, when mass appears or disappears in a process, the total energy stays the same because that mass is just turning into energy or vice versa. Think about nuclear reactions, like in the sun or nuclear power plants. A tiny bit of mass is converted into a large amount of energy, which we see as heat or radiation. This doesn't break the rule of energy conservation because the total amount of mass energy remains constant. From a thermodynamics point of view, the first law focuses on energy in the forms of heat, work, and internal energy. But mass energy equivalence expands this view by showing that mass itself is a stored form of energy. Any change in mass within a system means a change in total energy. For example, in particle physics, when particles collide or decay, their mass changes, and so does their energy. This is why in high-energy physics, scientists always account for mass changes when calculating energy balances. In everyday chemical reactions, the mass change is so tiny it's almost impossible to notice, but the principle still applies. So, the connection between mass energy equivalence and energy conservation is about broadening our understanding. It shows that energy isn't just about heat or motion but also includes mass as a form of energy. This way, the total mass energy in a closed system remains constant, aligning perfectly with the first law of thermodynamics. It's a powerful idea that helps explain how energy works at both the tiniest and the most energetic scales in the universe.